Hello guys, welcome to Textport 101. Today we are going to learn about depth first search and breadth first search. So this is a very important topic, important concept for programming interviews and programming questions. So our first topic is breadth first search. There might be a question in your mind that why do we use breadth first search, or where do we use breadth first search, or what are some real life examples or applications where breadth first search is used. So here is your answer. Breadth first search is used to find the shortest path between nodes in an unweighted graph. For example, Google Maps is a navigation system which finds shortest route between two places. That is kind of similar like finding shortest path between two nodes. So here in navigation system like Google Maps, breadth first search is implemented. Another example is social networks like Facebook to find mutual friends between two people. So there are some steps for implementing breadth first search. Step 1 is to visit parent node. Step 2 is to visit all child node of the parent node from left to right. And in step 3, we apply this pattern from left to right for current node, because your current node is your parent node for this instance. We'll see how exactly this is implemented. This is the implementation of breadth first search. So we use queue data structure for implementing breadth first search. And at the first instance, right now we have already enqueued the first node, which is the parent node or the root node of the graph, into the queue. So in the next step, the procedure is to dequeue the queue and enqueue all the child node of the dequeued node into the queue. This is the implementation. So when we dequeue the queue, our A node is deleted from the queue, and all the child node of the node A, that are B, D and G nodes, they are enqueued into the queue. Now you can see our queue is B, D and G. Now when we dequeue the queue, node B will be deleted from the queue and child node of the node B will be enqueued into the queue. So child node of node B is node C, so B is deleted and C node is inserted into the queue. In the next step, when we dequeue the queue, the node D will be deleted and the child node of node D, which is node E, will be inserted. So our queue is G, C and E. Same in the next step, node G is deleted and child node of node G, which is node H, is inserted or enqueued into the queue. For the next step, when we dequeue the queue, node C will be deleted, but there is no child node of node C, so there is nothing we need to do about node C. In the next step, when we dequeue the queue, node E will be deleted, so we have to insert child node of node E, which is node F. So our queue will be HF. So this is implementation of breadth first search. Now we'll go to the pseudocode of breadth first search. Pseudocode is basically informal description of the implementation or the program. This is how program is informally described. So the pseudocode is, first thing we need to do is enqueue root node into the queue. That is the same thing we did in the implementation. In the example, the root node A, which was already enqueued into the queue. So first thing is enqueuing root node into the queue. Now we are taking while loop, which means the condition is queue is not empty, which means that until the queue is empty, until we have searched, we have finished our search, until we have reached to our last node, our while loop will keep running. Now inside the while loop, the first thing we are doing is dequeuing the queue. Now when we dequeue the queue, there is one node which is dequeued. So if that node is last node, we will return. That means our program is completed because we reached to the last node. But if it is not the last node, we are enqueuing all the child nodes of that node. Right, this is the same thing which we have done in the example. So this is the best for depth first search. So why do we use DFS? DFS is used to traverse the graph using recursion. Or DFS is used to check if two nodes in the graph are connected with each other or not. Taking a real life example, DFS is used to find your way out of a maze using backtracking. So assume you are in a maze and you want to go after the maze, so you are walking through a path, but that path is not your way out, or it has a dead end. So what you will do is come back a little bit and choose another path. This coming back a little bit is known as is similar as backtracking. Then this whole phenomena or whole thing can be implemented using depth first search. So there are some steps for implementing depth first search. Step 1 is to visit the parent node. In step 2, you visit left child node of the parent node and go ahead up to last left node. In step 3, you visit right child node of parent node and go ahead up to last left node. We'll see the implementation. So this is the implementation. At the first instance, what you will do is we'll visit the parent node of the graph as written in the step 1. So right now we are visiting the parent node, which is node A in this case. After that we'll visit the left child node and go ahead up to last left node. But in this case we have only one child node of the parent node, which is node T, so we'll visit the node T. After that we'll visit the left child node as written in the step 2. We'll visit the left child node up to its last left node. So left child node is B, last left node is C. Now there is no other way, or there are no other child of node C, so we'll backtrack to node T. Right now we are on node T. Now we will visit the right child node up to its last left node. So right child node is node E and its last left node is node F. But there is no other way, or there are no other childs. This is the right end, so we'll backtrack to node T, and after that we'll visit the right child node up to its last left node. So it's like G and H. So this is the implementation of depth first search. So this is pseudocode of depth first search. Pseudocode is something, as I said, informal description of the code. So what we do is push root node on stack. After that we are taking while loop, which says stack is not empty. That means that while loop will run until stack is empty. So in the while loop, what we do is pop a node from stack. At the first instance, only one node is inside the stack, which is root node. So we'll pop the root node from the stack. If that node is last node, that means if this is the last node, our search is complete, our traversal is complete. So we'll exit the loop. If it is not the last node, we'll push all children of that node into the stack. So this is the pseudocode of depth first search. Now we'll compare BFS and DFS. So time complexity is same for both. Space complexity of DFS is lower than that of BFS. So we can say that DFS is kind of memory efficient. Another point is BFS can be represented with queue, whereas DFS is represented with stack. So that's all for today. Keep watching, keep liking, keep sharing, keep commenting.